These notes are going to go over how to use the periodic table to help us figure out our electron configuration. I find this to be a exceptionally great tool for doing this, and once you get the hang of it, it makes your electron configurations much easier to figure out. So we'll still use arsenic as our example as we did in the last video. There are a couple of things that you need to know about your periodic table before we get started. The first thing is, and again, I always use the periodic table that I share with you in class, so I highly recommend that one. You'll see that my periodic table, as well as other ones, already have your periodic table labeled by S block, D block, P block, and F block. But if not, it's nice to sort of have that drawn on your periodic table somewhere. So your S block is always these first two columns right here, and that includes helium as well over to the right. Your P block are these 6 columns to the right. Your D block is this dip in the middle. And your F block is that set of elements down at the bottom. Now, this particular periodic table is a little bit different than the one that I share. So the one that I use only has 14 columns that go across, so I scribbled out that last one. I think that would be helpful if you did the same. Okay, so let's go ahead and get started with talking about this. So the first thing that is really helpful to notice is that your S block is only 2 columns wide. So 1, 2. Technically, this is the second one for that first one, but 1, 2, 1, 2. Okay. It's helpful to note that your P block is 6 columns wide, so 1, 2, 3, 4, 5, 6. That your D block is 10 columns wide, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that your F block on your periodic table is 14 columns wide. Okay. So that's the first thing to note that is really helpful. The next thing to note that is really helpful is your periods that are indicated on the left side of your periodic table. So 1, 2, 3, 4, 5, 6, 7. And just as a remember, these correspond to your energy levels. So like which floor you're on, if you liked that analogy. All right. The next thing that we need to note is that we read our periodic table from left to right. I know this is going to seem obvious, but we read it left to right, top to bottom. So we read it like we would read anything else. So once you have that figured out, there are just a couple of additional things. If we look at your S block, you would refer to this first part as 1S. So first energy level, S sublevel. So this is 1S, this is 2S, this is 3S, this is 4S, 5S, 6S, 7S. All right, because we're in the S block, and then each of those correspond to their energy level. So then your P block is the same thing. So your P block, you'll notice, doesn't start until energy level 2. So this is 2P, 3P, 4P, 5P, 6P, 7P. Okay, so this part gets a little bit weird. Our dip or our D block is off by 1, and if you look at your notes from before, you'll notice that the D block starts on the 3rd energy level. So for our D block, this is going to start at 3D. So I know we're at 4S, but our D block starts at the 3rd energy level, so we're going to call this 3D. This is going to be 4D, this is going to be 5D, and this is going to be 6D. And then just for extra fun, if you take a look at your notes, you'll notice that the F block doesn't start until the 4th energy level, so this is technically 4F, and this is 5F. And if you're looking at your periodic table really closely at the atomic numbers, you'll notice that this whole row actually belongs here because it should go 57, 58, 59. And then you'll notice that this whole row actually belongs right up here because the number should go 89, 90, 91. So those are some extra tidbits. All right. So just as a reminder, your S block is one orbital, so one little spherical orbital, and it can hold a max of 2 electrons. Remember that your P sublevel has, those are terrible looking orbitals, but it has 3 of them, so it can hold a max of 6 electrons. Your D block has a total of 5 orbitals. Each one looks like a little clover thing. I'm going to draw 5 of these, but just pretend like, well, I'll just keep drawing them. I think one of them looks like this. Huh. Anyways, it has 5 orbitals, and so it can hold a max of 10 electrons, and I am not going to draw the F ones because that would take forever, but it can hold a total of 14 electrons, which ends up being really helpful because if I look at my periodic table, S block holds 2, 1, 2. The P block holds 6, 1, 2, 3, 4, 5, 6. The D block holds 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You kind of get the drift there. Okay, so now I'm going to use all of this information on my periodic table to help me write the electron configuration for arsenic. Now, arsenic is over here on my periodic table, and I'm going to read my periodic table from left to right, and then top to bottom. So after I read the first row, then I'll read the second row, and then I'm going to read the third row. And then I'm going to read this fourth row until I get to arsenic. So if I'm reading my first row, that means that I'm going to fill up 1s, and I'm going to fill it up all the way. I'm going to fill up 1s1 and 1s2. And then I'm going to go down to my next line, and my first thing that I'm going to fill is 2s. So then I'm going to fill up 2s1, 2s2, and then if I go across, I'm going to fill up 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. So I'm going to fill it up all the way through 2p6. And then I'm going to read down my next line. So I read this line. Now I'm going to read this line. I'm going to fill up 3s, and I'm going to fill up 3p. So 3s is filled all the way. 3p is filled all the way. And then I'm going to read my next line up until I get to arsenic. So I'm going to fill up 4s, then I'm going to fill up 3d, and in order to get to arsenic, I'm going to fill up 4p1, 4p2, 4p3. So that's going to be, need a little bit more space here. 4p3. And if you look at the electron configuration we did for arsenic before, this was the same electron configuration we came up with last time. Okay, just for the sake of fun, I'll do one more with you. Let's do a long one. We can do silver. So silver is over here. So again, I'm going to read my periodic table. I'm not going to write as I go, but I'm going to fill up 1s. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4D, and then I'm just going to go to silver. So 41, 42, 43, 44, 45, 4D6, 47, 48, 4D9, 4D9. Sounds funny. So then you can write out that whole thing. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and then it was 4d10, and this is the electron configuration for silver.